Today, we are experimentally proving Pascal's principle. Using a hydraulic lift, let's see how a small force can lift a massive object. Here, a person stands on piston 1. The mass of the person is 1 unit, while the car on piston 2 weighs 20 units. The weight of the car is 20 times heavier than the person. When the person stands on piston 1, their weight exerts force, creating pressure in the hydraulic fluid, according to Pascal's principle. This pressure is transmitted equally throughout the fluid. The pressure reaches piston 2, which has 20 times the area of piston 1. This larger area generates enough force to lift the car. The area ratio of piston 1 to piston 2 is 1:20. This means a small force on piston 1 can lift a much heavier load on piston 2. If we double the mass on piston 1 to 2 units, the car is lifted even higher. A small increase in force creates a significant effect. Now, let's increase the area of piston 1 to 3 units. What happens to the pressure? With a larger area on piston 1, the pressure in the fluid decreases. This reduction in pressure means piston 2 can no longer support the car, causing it to lower. To lift the car again, we need to increase the pressure. Let's add more mass to piston 1. By increasing the mass, we exert a greater force, which restores the pressure in the fluid. With the increased mass on piston 1, the pressure rises again. This higher pressure is transmitted to piston 2, lifting the car once more. So, Pascal's principle demonstrates how pressure, force, and area are interconnected. By adjusting these variables, we can control the lifting or lowering of heavy objects with precision. Thank you.